for this video is chemical names and formulas. The essential questions are: how do you recognize an acid, how do you write names of acids, and how do you write formulas for acids. So to recognize an acid, they have to have a hydrogen paired with an anion. We have two types of acids. The first type is called binary, and it basically means that there's no oxygen in the acid. To name these, you write hydro, and then the stem, and then it ends in IC, and then you add acid. So, for instance, this one has a chlorine in it, so the stem is chlor, so it's hydrochloric acid. So the hydro in front of the stem, the IC on the end, and then acid. The next one is fluorine, so this is hydrofluoric acid. The next one is cyanide, so it's hydrocyanic acid. To write the formula, all you have to do is look at the stem and figure out what anion it is, and then add hydrogen to it to make it balance out. So hydrogen and hydrobromic will be hydrogen and bromine. They're -1 and +1, so they cancel out, so you just get HBr. For hydrosulfuric acid, that is hydrogen and sulfur. Hydrogen's a +1, but sulfur is a -2, so you're going to need 2 hydrogens and 1 sulfur to balance out. The other type of acid is called an oxyacid, and basically these are the polyatomic ions with the hydrogen attached. Okay, and so if the polyatomic ion ends in -ate, you would change it to an ic acid, and if it ends in -ite, you change it to OUS and an acid after that. So this first one is nitrate. There's going to be no hydro in the name. This first one is nitrate, so we change it to ic, so it's nitric acid. The next one is nitrite, so that changed to OUS, so it's nitrous acid. Okay, our SO4 is sulfate, so that's going to be sulfuric acid. And the next one is sulfite, SO3, so that's sulfurous acid. To write the formula, you just go in reverse. So if it ends in IC, it used to end in ate, ATE, so acetic acid would be acetate. And hydrogen is paired with it, and we need the charges to cancel out. That's a +1 -1 situation. So it's going to be HC2H3O2. And we leave the H in front to show that it's not part of the ion. Oxalic acid, it ends in IC, so that would be oxalate. So that's H+ for the acid portion, and C2O4 is oxalate. It's a 2- charge with a 1+ charge, so we need 2 hydrogens to cancel it out. So I have H2C2O4. Phosphoric acid is going to be with phosphate. So I have H+ for my acid and PO4, which is a 3- charge, so I'm going to need 3 H's, so H3PO4. And phosphorus acid used to be phosphite, so it's PO3. It's still a 3-, so it's going to be H+ and a 3-, so that's H3PO3.